Okay, this question sounds a bit confusing because they give you the maximum volume of the cone. They ask you what R is. So I'm going to ignore that to a certain extent and think about how would I do this problem if I want to find the maximum volume of a cone in a sphere, right? So just draw an approximate picture here. Okay, so that's a center. That's a big R. That's a small r in the bottom of the cone. And this length right here is the height, right, from here to here, all the way from here to there, right, minus the radius of the sphere. So keep that in mind. Now, to optimize a cone, I need to deal with the volume of the cone. And usually what we do is we convert this into one variable in terms of all R or all H on the right side. Now, the triangle I labeled, big R, small r, H minus R, it satisfies this condition. The R squared is equal to H minus R squared plus the small r squared. Okay, so let me expand that. So that crosses out. And we have, okay, so if I isolate that r, small r, I get 2h r minus h squared. So if I replace that with this, I get equation of the volume all in terms of one variable, height. Now keep in mind that the big R, so we're assuming that sphere is a fixed volume. We're changing, given the fixed volume of the sphere, we're changing the radius and the height. Okay, so 2hr minus h squared h. So let me multiply that hn. So I can use a power rule to differentiate that. The derivative of v is 4rh minus 3h squared. Now when that's set equal to 0, that's where the maximum minimum value of the cone occurs. Okay. So the only way this thing will turn into 0 is if that will turn to 0. Okay, so we can factor out h. Now clearly, h is equal to 0 is not something we want. We don't even get a cone. So otherwise, setting that equal to 0 and isolating h, we get 4r over 3. Okay, so 4 over 3 of the r. So we have h in terms of the big R. And if you replace the h in terms of r right here and right here, we can express the r, the small r, also in terms of the big R. Okay, so what I did was replace that. That's that. That minus h squared is this thing here. Okay, so multiplying 4 and 2 and squaring this whole term, I get this. Okay. So common base is 9. So 24r squared minus 16r squared. Which means r squared is equal to 8r squared over 9. So r is then root of 8 over 9, which is 2 root 2 over 3 r. Okay, so now I both have h as well as the small r in terms of big R. Now we can go back to the original cone formula and let's plug in all the information. Okay, so if we plug in the small r and the h, and the volume is given to be 4 pi over 3 right here, right? You can see that the only unknown that we have is going to be big R. So let's do that. Actually, it's r squared here, so we can just plug that in directly instead of squaring it after. So let's just replace the entire r squared with 8r squared over 9 and h with 4r over 3. Okay, so pi over 3 gets reduced because if you just multiply both sides by 3 over pi, those are gone. Okay, we can reduce to 4. And we get 8 over 27 r cubed is equal to 1. So r cubed then is 27 over 8. They're perfect squares, perfect cubes. So r will be 3 over 2.